this video, we will be working with matrix operations. Our objective will be to perform addition, subtraction, and scalar multiplication on matrices. Our first vocabulary would be matrix. A matrix is a rectangular arrangement of numbers in rows and in columns. The dimensions of a matrix, m rows by n columns, would be written as m by n. So we start with the rows and then the columns. An entry, or element, is each member of the matrix. The first thing that we want to talk about is to decide whether two matrices are equal or not. The first thing we take a look at to determine whether they are equal or not is their dimensions. In this case, when we take a look at these two matrices, they both are 2 by 2 matrices. 2 rows by 2 columns. So the size is equal. But in order for matrices to be equal to one another besides size, their elements or their entries need to be exactly the same. So let's take a look. In the upper left-hand corner, the first entry or element is 2.5. In this matrix, the element or entry is 5 over 2, which is also 2.5. Those are equal. In the upper right-hand corner, we have -1 and -1. In the lower left-hand corner, we have -0.2 and -1/5, which when converted to a decimal is -0.2. In the lower right-hand corner, we have 3 and 3. So the elements or entries are the same, as well as the size. So yes, these are equal. Let's take a look at the example on the bottom of the page. First of all, we take a look at the size. This one measures 2 by 2. The dimensions of this matrix are 2 by 2. But let's take a look at the elements. The upper left-hand corner in each are not the same. 1 is not equal to 0, so these are not equal. Now we would like to take a look at addition and subtraction. The first thing that we want to take a look at is to make sure that the matrices are the same size, because in order to add or subtract, they must be exactly the same size, because our resulting matrix would be that size. In this case, our matrix and this matrix are the same size, so it's very simple. When we add them together, we simply add the same positions together. So we'll add the 0 plus the 1, and that is our new element. We add the 4 and the -9 together, which gives us -5. And then we add the 3 and the 8 together, which gives us 11. So the sum of these two matrices is now 1, -5, and 11. Let's take a look at the next example. The first thing we need to do is to make sure our matrices are the same size. Both of them are 2 by 2, and our result then will be a matrix that is the same size, a 2 by 2. When we subtract these two matrices, we're going to subtract their entries. So we take 3 in the upper left-hand corner and subtract 2, which is in the upper left-hand corner of this matrix. 3 minus 2, the result would be 1, and it goes in the same position. In the upper right-hand corner, we have 3 minus the upper right-hand corner 0. 3 minus 0 would be 3. In the lower left corner, 9 minus -3, meaning 9 plus 3 would be the result of 12. And then -5 minus 5 would be -10. And that is our new matrix. In our last example, we can see that these two matrices are not the same size, and because they are not the same size, they cannot be added together, so this would be not possible. Now we are going to work on scalar multiplication. When we multiply 6 times this matrix, our result will be the same size matrix, which is a 2 by 2. It's kind of like the distributive property. We will multiply the 6 times each of the elements, and that result will be our new matrix. So 6 times 2 would be 12. 6 times negative 3 will be negative 18. 6 times 8 would be 48. And 6 times 4 will be 24. And that is our new matrix. In our next example, we have two operations going on. We have our scalar multiplication with our first matrix, and then we have addition. We also need to take a look at the size, and it looks like they are the same size. So the first thing that we need to do, similar to what we would do if we had distributive property, is to multiply the negative 1 times each of the elements in this matrix. So negative 1 times 4, we would have negative 4. Negative 1 times 3, we would have negative 3. And negative 1 times 2, we would have negative 2. Then we have negative 1 times negative 7, which would be positive 7. Negative 1 times 3 would be negative 3. And negative 1 times negative 9 would be a positive 9. Then we can add that to the other matrix, which is 3, 9, 1, 6, negative 8, and negative 4. And remember, when we add the two together, our resulting matrix will be the same size, and we add the same positions. So we're going to add negative 4 plus 3, which is in the upper left-hand corner, and that will be negative 1. Going down the column, we have negative 3 and 9. When we add those together, we have a sum of 6, and negative 2 plus 1 would be negative 1. Starting on my next column, I have 7 plus 6, which would be 13. Negative 3 plus negative 8 would be negative 11. And 9 plus negative 4 will be a positive 5. In our next example, we want to solve for the variables x and y. And to do that, we perform the operations and then we'll solve. So the first thing we need to do is to go inside the parentheses and add these two matrices together. First, taking a look at their size. They are 2 by 2s, and so we can add them together. So we have 8 plus 4 would be 12. 0 plus negative 2x will be negative 2x. Negative 1 and a positive 1 would be 0. 2y plus 6, since we can't add those together, will end up being an expression 2y plus 6. Alright, then the next thing we need to do is perform our scalar multiplication. So 4 times 12 will be 48. 4 times negative 2x will be negative 8x. 4 times 0 is 0. 4 times 2y and 6, we need to distribute both of those. So we'll have 8y plus 24. And that's equal to our other matrix. We have 48, negative 48, 0, and 8. Now we want to solve for our variables, so what we need to do is, because we found out that if two matrices are equal to one another, then their elements in the same position are equal to one another. So negative 8x is in the upper right hand corner as well as the negative 48. So we simply set those two terms equal to one another, and then we solve. So divide by negative 8, so x is equal to 6. Then we set this expression 8y plus 24 equal to 8. Subtract 24 from both sides. We have 8y is equal to a negative 16. And when we divide both sides by 8, we find out that y is equal to negative 2. Now, if you understand that, we could also take a shortcut. We could say, I just need to add these two elements together where my x is located. 0 and negative 2x would be negative 2x. Then I could multiply that by 4, which would give me my negative 8x, and I could right away set that equal to negative 48 and then solve. Likewise, I could say I have my 2y plus 6, which is right here. Multiplying that by 4, I could right away know that I have 8y plus 24 and set that equal to 8. If you understand just taking those specific portions out and solving, you're more than welcome to do that as well. Let's review. Matrices must be the same size to add or subtract. Matrices are equal only if the entries are equal to one another. When solving a matrix equation, simplify one side, then set the corresponding entries equal to one another and solve the resulting equations. And finally, remember that to multiply each entry by the scalar for the new matrix. Please remember to complete the reflection.